Hey guys, what's the crack? So in this video, we're going to go over Newton's 3 laws and then how to apply it with some examples. So first one, hopefully everyone knows Newton's first law. Newton's first law tells us if an object has equal forces on it, so equal forces in their opposite directions, we know that we can say the resultant force there is 0 newtons, right? So resultant force just means tells us what the difference in those forces are. So the resultant force is 0 newtons on the object. We know the object's either doing one of two things, right? Either the object remains at rest. So let's say this box was on the table. Someone's trying to pull it forward 1 newton, backward 1 newton. Because they're pulling at equal forces in opposite directions, the box is just going to stay at rest. Or it's going to continue to move at a constant velocity. So for example, if I have a car and my car is moving at maybe 20 meters per second in the forward direction, let's say we've got a forward force on it of the 1 newton and a backward force on it of 1 newton, it's just going to continue to move forwards at 20 meters per second, right? It's going to keep going at the exact same speed, not changing, because the forces on it are balanced. Okay, so that's Newton's first law. Newton's second law, you've probably seen the equation F equals ma. So what that tells us is if there is a resultant force, so F stands for resultant force. If there is a resultant force, there will be an acceleration. And another way you might see it written is force is equal to the change in momentum over time. Or we can say the resultant force is equal to the rate of change of the momentum. So what we're saying is if it changes momentum, and momentum is mass times velocity, so if there's a change in its velocity per unit time, there's going to be a resultant force on it. So let's say we look at this box. If I've got 15 newtons trying to pull it towards the left and 20 newtons to probably pull to the right, technically I just redraw that one box of having a total force, a bigger force of, what do we say, 15 and 20, a bigger force of 5 newtons trying to pull it towards the right. So the resultant force in that box is basically just having like one box with 5 newtons on it trying to pull it towards the right. Okay? Let's say we've got a box here, we've got to resolve the forces, okay? So when we're going to resolve the forces, you've probably seen from my earlier videos, the trick is, and you want to have fast tricks in physics, right? You don't want to be wasting your time. Yes, you can use Pythagoras, right? You can use trigonometry, use SOHCAHTOA. However, that's probably going to waste time. You just want to learn that any time you go through the angle, it's always cosine. So this one is going to be 6 cosine 50 if we're going through the angle, 6 cosine 50. If we're going against the angle, so we want to find that vertical component. If we're going against the angle, we didn't go through the angle. If you went against it, like going against God is a sin, that would be 6 sine of 50, right? It's a sin to go against it. So what I've got now on that one box, you can see I've got a total force pushing it towards the right of 5 plus 6 cosine 50. And we've got a total force trying to push it up of 6 sine of 50. So 5 plus 6 cosine of 50 in your calculator. So what I would do is make sure your calculator is read mode, do cosine of 50, we're going to multiply it by 6, and we're going to add 5, and we're going to get a total number there of, technically, instead of writing that, we can write that becomes 8.86, and we can do sine of 50 multiplied by 6, and to see that upward force there becomes 4.596 or 4.6. So we say that's 4.6. So you think I still have not resolved that. So what I've got now is a force going towards the right of 8.86 newtons and a force going upward of 4.6 newtons. So clearly now I can use Pythagoras to find what that resultant force in that box is. So I know what I can use here is I can use a squared is equal to b squared plus c squared. So to find what this component is, because of my right angle triangle, all I need to do is 4.6 squared. I'm going to add 8.86 squared, and then we take the square root of our answer to find out what that final resultant force on that box is, which is 9.98 newtons. So the resultant force in this box, I can just draw one box now, and we can say in that one box, I've got a force of 9.98 newtons on it. And we can even find out what that angle is, right? Because if I want to find out what that angle is above my horizontal, I know that I can do tan of theta is equal to opposite over adjacent. So what I've got here right now, and I know that tan of theta is equal to opposite over adjacent. So my opposite is my 4.6, so tan of theta is equal to my 4.6, over my adjacent is my 8.86. So to find what theta is, we just do inverse tan or shift tan. And what we're doing here is our 4.6 divided by our 8.86 to get our angle there to come out at 27.4 degrees. So I know the angle there is going to be 27.4 degrees. So instead of having these two forces and one force at an angle, we find out we can resolve these forces to find out what that one force and what angle is on that box. So another example here is we've got a box and a slope. So let's say we want to calculate the friction if it's going down the slope. So now friction, if it's going down the slope, it's going to oppose the motion. So friction is going to be going up the slope. And I've got weight pulling down the slope. And again, I've got my normal contact force that's perpendicular to the slope, because the normal contact force always acts at right angles to the surface. So what we're trying to do here is calculate the friction if it goes down the slope. So we know it's down the slope at that 1 meters per second squared. So I can find the resultant force is mass times acceleration. The mass is 2, the acceleration is 1, so that resultant force is 2 newtons. So what I know is there's going to be a force pulling down the slope that is bigger by 2 newtons. Okay, so to figure out what is that force pulling down the slope, and I can see here I can resolve my weight. My weight is going to have some component that's perpendicular to my slope and some component that is parallel to my slope. So I need to find out what that angle is there to make my life easy. So that angle there is 15, this angle is going to be 90, this angle here is going to be 90, take away 15, so that's a right angle again, this angle in here is going to be 15. And again, from this rule up here, when we go through the angle is cosine, if I go through the angle, it's cosine. So that's going to be my W cosine 15, and this way is going to be my W sine of 15, because we didn't go through the angle trying to resolve it in that direction. Okay, I can write W differently because I know W equals mg, right? Weight is equal to mass times by gravity. So the mass was 2 and the gravity is 9.81. So what I can do now, if I want to find what friction is, again, I know this downward force is bigger by 2 newtons. So I know that 2 times by 9.81 multiplied by sine of 15, if that force is bigger than by 2 newtons, so that force take away 2 is going to end up what my friction force is. So on your calculator, all we're going to do now is my sine of 15 multiplied by 2 multiplied by 9.81, and then we're going to take away 2 to find what the size of that friction force is, and it comes out at 3.08 newtons. So that's that one done. Okay, Newton's next law is, you might be thinking about Newton's third law. So Newton's third law is over here. So Newton's third law tells us if object A exerts or puts a force on object B, object B exerts an equal but opposite force on object A. So for example, if you're thinking about your nucleus, right? So we know your nucleus is positively charged because you've got your protons and your neutrons in there. And you've got your electrons that are trying to orbit that nucleus. So we know there's going to be a force of attraction of the electrons trying to be pulled towards that nucleus, but there's going to be an equal but opposite force of the nucleus pulled towards the electrons. That's what Newton's third law is. So you can see Newton's third law is the same type of force. It's both that attractive force, it's the opposite directions. So same type of force, opposite directions, because it says here opposite force, and equal in magnitude. So it's an equal magnitude, opposite force, same type of force, and they act on different objects. So if I look at my sample here of a book on a table, I know if I was doing Newton's third law, what I could say is the book puts a force on the table down, the table puts an equal but opposite force on the book up. Okay? If I was looking at another third law pair, I can say that gravity pulls the book down, so the gravity pulls the book down, and then the earth gets pulled up by the book. So the book gets pulled down due to gravity or due to the force of the earth gets pulled up due to the book. Okay, because remember, gravity exerts force on masses. You might think, how is the earth pulled up by the book? And it just doesn't move because it's much, much larger than the size of the book. Okay, so there's my Newton's third law pairs. The book puts a force down on the table puts an equal but opposite force on the book. The earth or gravity pulls the book down, the book or gravity pulls the earth up. Okay, so we're thinking, how does the book, what's happened to the book then? So if we look at just the book itself, forces on the book was the force upwards on the book due to the table and the force downwards on the book due to gravity. So if I was to look at just the book by itself, again, what we can see here is we have just the force acting the book pushing it up from the table and just the force acting the book pulling it down to gravity. And because they're equal forces on the book, that there is Newton's second law. So Newton's second law is on the book, there's equal forces There's no resultant force, so then Newton's first law tells us that it's going to be balanced. Okay, so again, Newton's third law acts on different objects, so that's the difference.